So, hello everyone, and welcome to the DRBF Offshore Task Force first webinar of the 2024. I am Georgiana Takuc, President of the DRBF Board of Directors Region 2, and I'm your host for today. For those of you new to DRBF, the Dispute Resolution Board Foundation was established in 1996 by the creators of the dispute board process, with a mission to develop dispute avoidance and effective resolution for construction projects. Today, the association has over 1,400 members in over 70 countries. And as this dispute board process has expanded worldwide, it is now used on a variety of projects and long-term contracts of many types and sizes. The DRBF develops best practices and offers training and educational resources for project owners, contractors, and DB practitioners. And it partners with other industry organizations to adapt the DB process to new sectors. It may be of interest to note that DRBF is publishing a guide to best practices and procedures, the DB manual, now available not only in English, but also in French, Spanish, and Portuguese. And come back to our topic today. Today, we're going to discuss industrialization of the offshore wind and its impact on dispute boards. Well, everyone talks about the importance of the industrialization of offshore wind industry and how collaboration and communications are essentials. But what is really all about, and why is it so important, and what are the challenges associated with it? Well, we'll find out today from our DRBF Offshore Wind Task Force speakers. And in alphabetical order, Dr. Carsten Galib serves as Principal Engineer at Inros Lackner in Bremen, Germany. He is an internationally recognized port engineer and engineering geologist with over 20 years of experience in the global construction industry. Throughout his career, he has effectively managed the planning, design, and execution of numerous marine infrastructure and offshore projects worldwide. Carsten actively participates in Engineering Advancement Association of Japan's type of contracts and FIDIC contracts as the owner's representative and FIDIC engineer. Additionally, he's a registered geologist and engineer in the UK and Germany, as well as a FIDIC certified adjudicator. Jared Monaghan is a chartered engineer with some 30 years of experience in the delivery of major construction projects in Ireland, but also internationally, with a particular focus on energy and renewables. He is an experienced ADI professional and is appointed regularly as arbitrator, adjudicator, mediator, conciliator, and dispute board member. Gerard is a FIDIC certified adjudicator and member of the FIDIC President list of approved dispute adjudicators, and a member of the Minister's Panel of Adjudicators established in accordance with the provision of the Irish Construction Contract Act 2013. He's also the chairman of the Engineers Ireland Dispute Resolution Board and is the DRBF country representative for Ireland. Nicholas Rigby is a chartered engineer and fellow of the Institution of Engineering and Technology and has more than 35 years experience across the energy industry. He started NRG Management Consultancy to provide contract management and expert witness services to energy companies who find themselves involved in disputes. Nick has experience of dispute resolution across multiple jurisdictions and project types and is a member of FIDIC's task group developing a standard offshore wind contract, and he's also the co-chair of the DRBF Offshore Wind Task Force. His primary focus is on grid and offshore wind projects. And prior to starting Energy Management Consultancy, Nick was the head of contract management at Low Carbon Contracts, dispute director and head of strategy at RWE Energy. Tobias Voigt, since his admission to the bar in Germany more than 20 years ago, Tobias has been a competent lawyer who has accompanied complex engineering and construction projects worldwide in the area of infrastructure, energy generation, mobility, and process engineering. Tobias heads the working group on international construction law of the German Lawyers Association and is the chairman of the Offshore Dispute Resolution Committee of the World Forum Offshore Wind. And now, Nick, would you please start our journey and tell us what is industrialization of offshore wind industry?
Just sharing my screen. Can everybody see the full slide?
Not yet, please. Not yet. Just the... You're not in slide share mode?
I am. It tells me I am. But let me stop and start again.
Please.
Has that done it?
No, it still shows the next slide.
So you're looking at the which slide can you see then?
We could see the first slide on the left and the next slide on the right.
Oh, so you can see both slides.
Yeah,
Yes.
we see presenter mode.
Right. Okay. Let me switch. Hang on. I'll go back again. It's my fault. I was playing around with this earlier.
Well, if you want, I could. Okay.
That should have done it.
No. Oh, now it is. Yes.
Okay, we're good to go.
Yes.
Right. Okay. So I'm going to be addressing the question of what is industrialization. If we consider the growth that is expected in offshore, then that is going to be very significant, and obviously the construction spend will go with that. Although the spend in terms of per megawatt, one would hope will reduce with industrialization. So growth is a given. And if we think about the processes associated with a new industry, so in development, you tend to build, then you measure, and then you redesign. Once you need to build and operate at scale, you can no longer afford to have let's say, such a learning process. You're still going to learn because you're going to learn as you go along. You're going to tweak, make small changes, but you're going to repeat. And you don't need to finish the first project before you move on to the next. So if we're going to build the growth that's shown on the first slide, we're going to need to have the second approach where we don't need to complete all of the processes and understand what's happened before we move on to the next project. But let me give some good examples of where industrialization is currently happening. So first of all, the standardization of contracts. It's important that both contractors and developers know what the contractual obligations are of, in relation to the work they're doing. So standardized contracts are a key part of that. And there's 3 organizations here mentioned who are working on standardized contracts. And I also heard the other day that Logic, the UK oil and gas industry, is also looking to develop a contract for offshore wind, which is interesting because the IMCA contract is actually heavily based on Logic anyway. There's universal standards. There are many standards already in offshore, but organizations like the Energy Cluster Denmark are doing more work to develop contracts that can be used, standards that can be used. There's also a need to coordinate as long as you also compete. And so a good example here is the Vestas and Siemens Gamesa initiative, where they are enabling the standardization of the equipment needed to transport components. And this means that vessels will not have to be subject to a major new work to adjust the marine spread when they are being taken from jobs that, where all of the users are using the standardized approach. And of course, speaking on behalf of the UK, which is a market I know best, but I know that many other European countries are doing the same. There's been a lot of research done by, let's say, quasi-state bodies such as the Offshore Renewable Energy Catapult, and also funded by Crown Estate. But where are the gaps? Where do we need more change in order for industrialization to happen? So just to give some examples, we have the dilemma about the increasing size of turbines. Currently, vessels are being designed and built to install 25 megawatt turbines. But the vessel owners are concerned that they're going to develop these vessels. They'll be used on a few projects, and then let's say 10 years down the track, somebody will be turning to them and say, but now we've got 35 megawatt turbines. So have you got a vessel that can do that? So the vessel owners need commitment. And in my view, it's down to the developers who are committed to the long-term growth to also commit to vessels, which will enable the vessel owners to be confident that they're going to be able to use all the vessels that are currently being designed and built. I've already mentioned technical standards. This is an important area. There's also the issue that we need to place more reliance on the providers. We don't want a repeat of the grouting issue that occurred on a good 6 or even more wind farms. And finally, there's the actual speed of transition in terms of the way we can consider to be the development of components and their installation being almost on an industrial process scale. Now, the unitary nature of a wind farm, it helps here because obviously you do the same product numerous times on the wind farm. And then a question which is relevant in relation to offshore wind, floating offshore wind, is how many demonstration plants does one need to produce before you can start to build at scale? And that's something that will need significant thought as we move into floating wind. So I'd like to now hand over to Carsten, who's going to talk about port industrialization.
Okay, thank you, Nick. 1 second.
Maybe until Carsten gets online with his presentation, can Nick tell us a bit of, you mentioned turbine capacity. What will be an optimum turbine capacity?
Well, that's a $64,000 question, really. I mean, onshore, I always used to say that onshore would never rise significantly above the level that we had about 10 years ago. And there I was proven wrong. But I think there is an issue about physically getting turbines and the equipment to site, which impacts on onshore, but that doesn't apply to offshore. Anyway, maybe we'll come back to that later, but back to you, Carsten.
Okay, thank you, Nick. Can you see my screen, my presentation?
Yeah, that's good.
Okay, all right. Thank you very much for the introduction. My name is Carsten Galeb. I'm a port engineer working for Industrialisation in Germany. And within the next minutes, I'd like to highlight the importance of industrialization and port construction in driving the progress of offshore wind projects and the application of dispute boards in port construction projects based on my own experience. Because to ensure successful growth of offshore wind projects, it's crucial to understand the role of industrialization and port construction in offshore wind projects, because ports contribute significantly to the development, efficiency, and economic benefits of offshore wind initiatives. Oh, how can I get to the next slide? Okay. With this slide, I'd like to explain the function of ports in the offshore supply chain and industrialization, because ports, due to their function as a logistic center, and as an interface between land-based and maritime activities. They play a crucial or critical role in the success of offshore wind projects during the entire life cycle, from the planning stage through the construction stage, manufacturing, procurement, and installation and stacking of offshore wind components, through the operational phase up to decommissioning. Although the importance of dedicated port facilities for the offshore wind industry differ during the different development phases. For example, during the planning stage, offshore wind projects do not have unusual requirements for port facilities, because at that stage, ports are mainly used as home base for survey vessels, for wildlife surveys, bathymetric surveys, or geotechnical investigations, and ports are already available for these purposes, and also in a sufficient number for offshore wind use. And if not, these ports do not pose significant cost or acquisition and build challenges that would impede further construction of offshore wind farms. But of course, this is different to the construction stage, because in order to support offshore wind projects, a combination of manufacturing, assembly, installation, and stacking ports are needed, which have different needs compared, I call them, standard or traditional ports. And when focusing on ports as enabler for offshore wind projects, it's particularly important to mention the installation phase. Ports used during that stage are known as stacking or marshalling ports, and are required to be in relative proximity of the offshore wind site to reduce the duration of installation and to optimize the use of weather windows. Which is mainly driven by the fact that leasing specialized installation vessels which are used to shuttle and install the components are very high. And a marshalling port also serves as a marshalling yard for receipt and storage of the components. So it's somehow a station where distributed production lines were put together into sub-assemblies, and various other finishing operations are done. Therefore, to allow ports to fulfill their role as enabler, they must satisfy the demands of the offshore wind industry, which is different compared to the traditional port industry, which I like to highlight here in this table. When looking at the difference between standard ports and offshore wind ports, standard ports, the main cargo which is handled are break bulk cargo, dry bulk cargo, and in particular containerized cargo. New container terminals, new container ports have a water depth of 16 to 18 meters, which provides sufficient water depths to handle the so-called new Panamax vessel with a draft of 15 meters. Here, the vessel shown here on this slide is the dimension of the new Panamax vessel, which is the maximum dimension to allow vessels to sail through the expanded Panama locks. Offshore wind ports requires usually only a water depth of 10 to 12 meter, which provides sufficient depth also for the larger installation vessels. I have here taken the dimension of the Seaway Strashnov, which is an installation vessel. But the main difference, and what is really challenging, is the different load capacity requirements. The load capacity requirements for a standard or traditional port, if general cargo is handled, is 50 kilonewtons per square meters, which is about 5 tons per square meter. But this is significantly lower compared to the requirements for offshore wind port, which have a range of load capacity at the berth around 200 and up to 600 kilonewtons per square meter at the stacking area. And the next slide, this also shows why it's not so easy to adjust existing port facilities into offshore port facilities, mainly due to the different load capacities requirements. In the next slide, I'd like to share my experience with dispute boards in port construction projects. So first one is an example why it is not a good idea to nominate or to appoint dispute members at the onset of the project. This project was for the modernization of an existing port facility, strengthening and deepening of quay walls. Contract amount was more than 113 million US dollar. The scheduled construction period was 36 months. At the beginning of the contract, the parties agreed not to appoint DB members only because of one reason: to save cost. The project was significantly delayed due to various reasons, amongst other things, COVID, and the taken over certificate was submitted with a delay of 16 months. After or during the DLP, the contractor issued a claim for prolongation cost of more than 28 million US dollar because during the contract period, the parties could not agree on the prolongation cost. The parties realized, because they did not appointed DB members, so there was no DB in place, the next escalation level as per contract was arbitration. And as we know, arbitration is more complicated and more costly than adjudication. So approximately 2 years after the project was completed, the party decided to nominate DB members, and since up to today, the dispute has not been solved. 2.5 years after the works has been completed. The other example is a good example why it is beneficial for all parties to agree on alternative dispute resolution procedures. It's about a project, port project for the construction of a new terminal for the oil and gas industry. Contract price was more than 90 million US dollar. Contract basis was the FIDIC Red Book 2017 edition. Contract period was 36 months. No delays. Taken over certificate was submitted after 36 months. Regular DAB meetings were held, virtual, hybrid, and face-to-face meetings. This supported the parties that any contractual issue could be clarified at the beginning and promptly. Although 2 disputes emerged, for which the contractor issued a notice of dissatisfaction, but the DAB decision solved those disputes during the contract period. And the cost overruns were less than 1.5% of the total contract amount. And this shows here the slide finally, what are the direct benefits of dispute boards if they are nominated at the beginning of the project. One point which should not be underestimated, if this is clear in the tender documents that there will be a dispute board, it may encourage the contractors to submit a decent bid, because then they think that there is a party who reminds the employer and also the contract administrator, if it's the owner representative or engineer or fitting engineer, to remind them of their contractual limits. And also what I noticed as a fitting engineer is that DABs or dispute boards have a greater power to enforce and contractual procedures or to provide advice and opinion for the interpretation of contract clauses. Because when I explain to contractors the contract procedures, they often think, oh no, you are the engineer, you are being paid by the employer, I don't trust you, which is of course not correct, but this is sometimes my impression. And last but not least, dispute boards can help the parties to promote a mutual resolution of contractual issues before they become a dispute. I'm sure there are more benefits, which I'm happy to discuss with you later. Thank you very much.
Thank you, Carsten. Tobias, until you get ready, I'm sure that you'll all have questions for Carsten. Some additional benefits you could also find in the dispute board manual that's available on the DRBF website. Tobias, can you stop sharing, Carsten, please?
Yeah.
Thank you.
Yeah, probably there are more questions after we had all presentations. What I thought might be beneficial kind of to combine that, this outlook of Nick and this very comprehensive insight in such a port project, because what we see in offshore wind is in the past, there were projects where you retained a vessel that was just a new build, not existing, or maybe with an upcoming crane upgrade, that would be a significant one, taking a lot of time, where I don't know if that would be ready for your project. But I'm convinced, as we have so few harbors, if we talk about industrialization, harbors that fit to the requirements that Carsten just referred to, we might also see projects where those harbors are not existing. And then because we have reservation periods, 3, 4, sometimes more years in the future for a project, where, of course, those topics then become crucial. And the big risk, if you don't handle that properly, it will just not be there for your project. And therefore, DAAB in place, in existence, right from the beginning, in a kind of overlooked, kind of neglected area of the business. A harbor should be there, yeah? But just compare the bearing capacities, as Carsten said, and you can extend that. Can you leave a harbor with your blades 150 meters sticking out sideways 75 meters from your vessel? Is that still possible in Bremerhaven when you say, I want to do it in Bremerhaven, for instance? No, it isn't. Yeah. And as Nick interestingly said, there is a nice initiative from Siemens and Vestas dealing with that. And I just quickly want to show you that article for everybody, because that's interesting to look up. If you just kind of Google Siemens Gamesa Vestas transportation initiative, you will find that quickly. And it tells us here, currently, whenever a wind turbine tower is shipped, the manufacturer welds a box onto the installation to which the tower is then clamped and is all removed later. So, of course, this is a kind of simplified journalistic reference to it, much more complicated. But industrialization really is in those little things, because my personal view that the OEMs, the manufacturers, will industrialize their turbines, I think that's still in future, that there's too much conventional manufacturing process involved with them. But you can save a lot of money and risk if you look exactly into those topics that we kind of, in that limited time that we have, decided to refer to. And this is vessels and harbors. Now I jump to my presentation as such, because I want to show now what that means if we combine now those two approaches when we discuss about marshaling harbor contract that you have to conclude as a developer, or the developer asks the supplier to retain a harbor or port to do exactly those kind of relay works that Carsten referred to. So to take in components, to kind of prepare them further and to ship them out into the offshore construction site again from there. So it might be a monopile coming from Rostock, entering Emshaven, getting some touch-up paint and maybe even secondary steel affixed to it, and then leaving for some German North Sea project from there. So such a contract has the challenge that, exactly as with a vessel, it deals with sequential business. So you're a terminal operator or a harbor operator, harbor owner, and the people line up and tell you, oh, I want your harbor for November 26 until July 27, and the next guy wants it, however, already in June 27. Basically, if you want to do something in the North Sea, you sit with Eemshaven and Esbjerg and have not much choice. And at the same time, the owner of such a terminal, that is not a kind of multi-billion-dollar business. Those are medium kind of sized companies. They can't accept risk profiles like a developer would do, like a RWE would do, or an EnBW or somebody, or Skyborn, you name it. So they sit there and have to think, okay, how can we deal with that business flow? And there will be overlapping, there will be gaps in between where you don't earn money. And so it's always then in the negotiation, the topic, when can I enter that site? What's the earliest start? When do we have to leave? What is with prolongation? What if my WTP supplier screws up and the loadout's not working, or the installation company screws up? I needed 3 months longer. But then the next project's already scratching the door and saying, I want to enter my harbor. And that is just a simplified view. That would be true for this article I just showed you, because the problem is much bigger, because the components you deal with is all sophisticated, engineered individual pieces, right? And everybody takes pride in it. That is so different compared to competitors. In addition, the developer has a bunch of 30 years experience engineers who accept only this or that of their preferred solution for something, how it should be engineered. And then basically what's the result? The harbor is not fitting to that. Exactly what Carsten, for instance, referred to. You might work with Bongassi mats and the like to simply stabilize a surface where you want to store something, but the OEM has a list of requirements towards the developer and says, I need a bearing capacity of 40 tons per square meter. Otherwise, you take the risk. So the developer has no clue. Harbor, that's really something remote down in the food chain. So he has no other chance to put forward that requirement, and would simply request the 40 tons per square meter, where the range of Carsten was something between 20 and 30, which is a standard or typical layout. How you would do it, still costly. But I also saw 50 or 60 tons, and then you negotiate, then you try to reduce that. The developer is not possible to, because he's frightened, not to diminish those requirements. And you end up in whatever you agree to, you probably have to adapt the harbor surface. Yeah, maybe not reinforcing from, I don't know, 7 tons to 30 tons, but there is something, because you can continue that. What is inclination of the site? Yeah? So the turbine supplier would generally request something below 1%, but then you already ask, how's it measured? 15 feet, 1 feet distance, how you measure that inclination, in this, how to put the gravel on site. Basically, it ends up that you have, on that kind of tight schedule, basically you have enabling works or upgrade works that are necessary to fulfill those requirements, which is always a little construction work project going on for somebody that is no construction company or no real estate developer that would, shovel gravel from A to B all the time, knowing all companies doing that with maybe exaggerated requirements coming from the OEM supplier. So the OEM will always insist on the maximum, on special layouts, and we have upgrade works, enabling works, often called. And everybody says, yeah, so we want to store, we want to load out sophisticated with wind factors, and the marine warranty surveyor will breathe down your neck telling you, no, that this will not work. Your loadout, stop your operation. That's everybody worried about, yeah. But that they do a little construction project or require the harbor to do a little construction project like Carsten and visit it, of course, in a bigger scale. But if you see the timely sequence, if you have a delay of 6 months only, or even 3 months in those upgrade works of construction works, just to adapt to very specific requirements that are very individual and not standardized, you might shoot out the whole chain of projects on that harbor if that's not working. And this is not considered as a major issue. So the major issue is fulfill my requirements, do load out, and the like. And this might easily kind of chunk up all the buffers that were available if something goes wrong, which for me points into two directions for this industrialization. The one, as Carsten said, do not neglect the difficulties of such a harbor upgrade project being required to facilitate an offshore project. So do it as conventional as possible in terms of accompanying it with the dispute resolution. And this should be also the interest of the developer, to have that in place, that not a little construction company now pulling out their reach stackers and caterpillars to harm the full project. And on the other hand, industrialization for me would definitely mean to look for the money efficiency also in those areas in terms of the requirements, so that everybody is clear. With exaggerated requirements, we would come to more port projects as described by Carsten, because we would have to reinforce bearing capacities to ridiculous limits, so that standardization or other topics relate to it, as I mentioned it. And basically, it's exactly the same topic with the vessels as it was shown in the article. So vessel is very apparent to everybody, and everybody probably in offshore saw sea fastening and certain decks layout stuff there, but it's the knowledge about the harbor site is relatively small, and also small with developers and everybody else involved there. So where I would say, and this is kind of my handover to Gerard, where I would say, especially the benefits of a DAAB, somebody underway, giving you also advice, telling you something, say maybe you're in the wrong direction. That is of very importance if you look into industrialization of those areas. And this is often, for the topic I spoke for, simple onshore knowledge or water construction related knowledge. It's not so much offshore knowledge that is needed there, which has to be infused into those processes. That's what I wanted to show you, a quick overview on a kind of often like an orphan. The harbor is often like an orphan in all this very important topics in such an offshore development. And maybe I could shed a little light on that. And I'm open for questions, of course. Thank you.
Gary, you're on mute.
Yeah, okay. Thank you very much, and good afternoon to all, and thank you for the opportunity to speak to you today. So what I want to do for the next 5 or 10 minutes really is to pick up on the various issues around industrialization and the standardization of contracts that Nick, Carsten, and Tobias has spoken about, and the impact that those practices and procedures that are going to be necessary for rollout of offshore wind, the impact that they will have on the proper and efficient operation of dispute boards as we know it. I mean, clearly the industrialization of the infrastructure, be it the ports or the harbours or the foundations or the grid connections or otherwise, will serve to reduce ambiguity as to what the size or the layout or the load bearing capacity should be. It should and ought to become standard. Nick mentioned learn, tweak, and repeat. I mean, I think it's a very good analogy. That is the way it's going to go. It's going to inevitably have to go. With that kind of knowledge and uniformity that the industrialization will bring in terms of the infrastructure, the ambiguity around what is required will diminish. Similarly, in terms of the standardization of contracts, you know, the roles of each party within a contract become better known, better understood. The risk balance, the risk share, the responsibilities of either party will be known intuitively for all contracts. You know, learn, tweak, and repeat. It'll be repeat across the world if the scale of the offshore wind generation capacity is to be achieved. So again, that knowledge and understanding of the contract forms themselves will reduce ambiguity, will reduce the grey areas. And it's in the grey areas that issues which can evolve or develop into disputes arise. So I think as a starting point, as a starting position, industrialization, uniformity, adoption of uniform standards, and the standardization of contracts should aim to reduce the number and amount of disputes, and should act as a fertile area or talking point for dispute board members at the dispute avoidance stage, because it's known. So if an issue is arising that you know parties should have known about, it's an industry standard. You know, you can use that to guide and to develop your informal opinion or assistance during site visits. But however, as you've seen, we've got a flavour of it today. The scale of the projects, the offshore wind projects, will remain huge, and the technical challenges will pertain. So, you know, areas of real difficulty will be interfaces between onshore and offshore elements, marine issues, vessel hire, weather, ground conditions. All of these issues will pertain, but it won't. The need for a dispute board, I think, as Tobias has rightly pointed out, will absolutely continue in terms of interpretation and the like. The factual matrix surrounding any particular dispute will be of huge importance. You know, all disputes have areas of facts, law, and quantum. You try and set out the factual background of an event. You apply the law to it, and you determine what the quantum will be if it's established in terms of time and cost. So whilst the legal aspects theoretically should be easier understood, the factual matrix, the factual background will be very, very important. And you need to really develop a dispute board panel that will understand the industry, understand the industrialization approach, and how the infrastructure developed and what it looks like, understand the complex forms, and be able to bring that knowledge and experience to the projects. We've seen very clearly from the two examples that Carsten mentioned earlier, you know, and they're absolutely black and white, I would say, as to the benefits of a standing DAB. As most of you will know, the approach adopted by FIDIC and other bodies really is heading to morph or evolve from a DAB or a DB to a DAB, a dispute avoidance and adjudication board. And to my mind, the avoidance aspect, particularly for offshore wind and for all projects, is key. And my view of the nature of the dispute boards, as I said, is you need to be really familiar with the standards, the uniformity, the specifications, and the like. As a view to offer a view then as to the real impact of industrialization and standardization, which is the topic of today's talk, you know, I think they'll go hand in glove together. Far from diminishing the need for dispute boards in these projects, I think they'll really act as an enabler. They'll coexist, and the industrialization and standardization should really act, in my mind, as a catalyst, particularly in the dispute avoidance phase, and act as a tool for dispute board members to really drive home the need and the benefit to avoid disputes and to get on with the delivery of the project. You know, these are important projects. Developers want to get them commissioned and operational and get them generating power and electricity. So that's what parties want. So you do not want to be involved in time-consuming and costly disputes. So very much so, I would say, Georgiana, that the impact of industrialization and standardization of contracts and the like would be a positive development for dispute boards, dispute board procedures and practices. So with that, I'll hand back to you.
Thank you. So until everyone gets ready for more comments, there is a question. Oh, it disappeared.
I answered it. Georgiana. It was a very
yes.
interesting question. So now it's unanswered.
Yes.
Because Ralph had asked the difference from 50 kilonewton to 600 is huge. Huh? Where does it come from? Yeah, so I said, if you take a 50 megawatt turbine nacelle, that will be more than 500 tons already. If you talk about monopiles, they will be in the 1,500, 2,000 tons nowadays. If you have those turbine sizes, of course, you put much more steel in your monopile, and those require those huge bearing capacities for. If you then think, for instance, also on the load out situation where this all comes down to certain crane stands that have to bear that, not just in the storage, but also for the storage, that's also significant. Yeah? So the HDQ, so the heavy duty key side, so to say, that has to have, of course, the biggest bearing capacity there. But that is really a big challenge if you now would say, okay, I do offshore wind in Lithuania, and then you have to turn around those harbors there, or do it in Finland, where maybe even for the Finnish projects, half of the time it's all on ice even. So this requirement-based, or this is the major difficulty, that this is so far off that regular business of a typical bulk harbor or container harbor that people, they normally tend not to grasp that problem fully, because that is why it was a beautiful question, because we see it also currently in Germany, where we have no proper offshore harbor currently. So every project goes to Esbjerg or Eemshaven, literally. And now our central government awarded subsidies to do a harbor in Cuxhaven. And all the conventional harbor operators are kind of lining up and saying, "Ah, we will do that." Basically, they have no clue what they are going into. Yeah, and they never negotiated with an OEM or developer that wants to put this full LD caps towards the little harbor operator if a cherry picker drops something, kind of, that is such a kind of huge inclination between their might and influence on the project, that this is really an interesting topic where, due to fear, a lot of efficiency is wasted, basically. You then stick to this kind of exaggerated requirements because everybody's fearing to do something wrong, where really knowledge has to be poured into, in my perception, to overcome that, to standardize, to industrialize, not to have a one-off project all the time where you start from scratch discussing inclination and the like.
Sure. Thank you, Tobias. You mentioned public subsidies, so that generally means public money, public procurement. And Harmert has an interesting comment, and perhaps Nick first, and then Jerry could comment on it. He's saying that an important aspect concerning the OWF ports is that there for new constructions or adaptation to the new loads, usually public tendering and awarding processes would need to be followed that often are rather time-consuming. I'm not wrong, I think UK has adopted a strategy to cut those time. And I think I've seen something along the lines for Ireland as well. So Nick, what can you tell us about?
Yeah, I mean that we do see in a number of countries where it's the old adage that build a shop and people will come and buy from you. I think I'm misquoting it, but a number of countries have recognized this and have made decisions to invest in their port facilities so that they are built to enable construction of offshore wind. And of course, one of the great things is that great things about Western Europe is that all of the ports can compete. So there have been a number of projects where part of the port work was actually done in a different country than the one where the wind farm was installed. And Tobias talked about particular issues associated with Germany, but that sort of approach of enabling your ports to be competitive in this market is definitely a crucial one. And governments want to encourage offshore wind. They offer different forms of subsidy, but actually offshore wind now doesn't really need a great deal of subsidy. But what is necessary is that port facilities are developed and developed early.
Yeah, and it's a very interesting question because, for instance, as Hartmut placed it, because if you take the Netherlands, they managed to get an exemption for energy business from public procurement law, right? So they run on lower restrictions there, but the harbor doesn't. Yeah, so that's exactly the problem. If you now say, okay, I have a heavy duty key of a certain length, and I want to extend that to serve 2 projects at the same time, for instance, to berth the vessels there. And your harbor is also agreeing to it. And so we might even do that, and you pay it off in 30 years with the port fees, and we finance it for 50 years. So this is how intelligent countries do it. Germany, they ask the private investor to do the whole financing, so that was kind of envisaged for Cuxhaven, which is completely stupid. So you go to your port authority and they say, yeah, we would do that. And everybody is kind of loves that outcome and is kind of relaxed that it was so easy because everybody wants to invest in port infrastructure. And then the Port Authority says, yeah, and we will run the public tender on that. And that takes XY months to do that. And those guys dealing with those works, they are not used to it because they have that exemption for the regular projects. And now this port thing where they thought, it's a little thing, please comply with our requirements. Please don't come in our way, little harbor. We have a huge project here. Now it comes up with public procurement for construction, kind of starting already with risks, how Carsten described them. There might be an overlooked bidder that loses out and files a suit against you, stopping the whole project. This is exactly very lovely question of Hartmut. This is where the devil is in detail. When we say, okay, we want to expand there is a lack of knowledge how to deal with how to identify and deal with all those risks, not only contractually, but simply also in terms of project management and the like. And there, this kind of advice infusion, as I would call it, is needed, as Gerard has described it.
And perhaps, Jerry, when you answer, would you add your perspective, please, on all these unknowns, if the input of a DB would benefit when you have more unknowns or not, especially that we know that in a public project, the tendency is, at least in this part of Europe, to delete provisions, as Carsten said before, just to apparently save some money. No dispute boards. Jerry?
Yes, well, thank you. I mean, it is an excellent question, and as Tobias has said, the ports and harbours are a real constraint. I mean, in Ireland, and I know we've Michael Farrington as a guest here today. He's a principal officer in the Irish Government Department responsible for offshore renewables. The potential for offshore wind in Ireland is often, we're often described as the Saudi Arabia for wind. But the constraint really is, there's numerous constraints, but at the moment, the only port on the island of Ireland that could deal with any offshore wind infrastructure of scale is in Belfast. So it's a huge constraint. The investment in ports and harbours needs to be made by the government, and a leap of faith, build it and they will come, as Nick has said. A leap of faith needs to be made. Procurement and planning are certainly the constraints. Planning, judicial reviews and the like are huge constraints. To your point, Georgiana, about dispute boards and the like, I mean, Ireland has been fairly well to the fore with developing dispute boards by way of standing conciliation in the public works contracts, which is a hybrid form. So I think there's a fairly good understanding of the benefits of dispute boards for all types of infrastructure, not least offshore wind in Ireland, and I very much hope that would pertain, particularly as you say, with the very particular challenges that can arise. So I think that's the view from that's the votes from the Irish audience, to use a Eurovision phrase. Thank you.
Thank you, Carsten. You had a positive experience and a negative experience about dispute boards into your projects. So a 50-50. Would you go for dispute boards?
Yes, I would. Definitely. If the DB members are carefully selected, and this is what I noticed, that sometimes DB members are selected because somebody wants to do somebody a favor. Let's put it that way. And not based on experience or knowledge.
True, that's true. Tobias, you can add on that, because you're working on some special rules for dispute boards for the offshore wind contracts.
Yeah, so that's exactly the situation. And there are many, due to bad experiences that stem from bad preparation, think that the procedure is bad and delete it from the contract, which is of course nonsense. Yeah. I sometimes also hear, like for adjudication, the supplier prepared for 2 years, submitted statement of claim, and we had 30 days to answer. That is, of course, a misunderstanding what is required on your claim management setup in your project. In such a situation, can't be that you are surprised by 100 million claim nobody knew of, that somebody has locked himself into a cabinet, worked that out, confronting you with that. So this is a typical situation that we see, of course, triggered also by legal departments that have to deal with those imperfections, let me say, from the project management phase, where people are gone, not available anymore. And to kind of make everybody acquainted with that process underway in the project also prevents that, because everybody's dealing with that board already, and not only in a function where 3 wise men or women sitting there telling you when nothing can be changed anymore, how it should have been and how damages are awarded now, but rather telling you underway, maybe you should work with Bongassi muds instead of doing a big load-bearing increase project on your harbor. That, in my perception, gives also a different attire towards such a board and how to get a real benefit from it underway, and not having it as a kind of distinct remote ivory tower thing that if everything's over will tell you the truth.
Thank you, Tobias. Jerry, you wanted to add something, please?
Yeah, I think it's a very important point, Georgiana, that Carsten brought up about the quality and the type of your dispute board members, and Tobias has mentioned it there. I mean, the skills, the necessary skills that you need to work effectively on an offshore wind project are fundamentally different to those you might need for, I don't know, highway construction or stuff like that. You know, it's specialized, challenging work. There's areas of interface, there's transmission issues, there's maritime issues, there's vessel issues. It's very, very important that the person, he or she that is the dispute board member, has experience and knowledge and capability in those areas if you to get the real benefit from the dispute board. There's also issues around multi-contract DAB. So offshore wind are developed by multiple contracts, and how that multi-contract DAB model should work. And I know it's something that we're looking at with the World Forum for Offshore Wind, and we may have a presentation later in the year on that very important topic. Thank you.
Thank you, Jerry. Anyone wants to add anything else? I see that everybody got clear minds. The presentations are good. No questions. Are they too shy to put some questions? Well, if you have any questions for us at any time, please do send them over via email, and we'll do our best to deal with them either directly or in the future webinars. If no one else has anything to add, then we are going to have another session on 19th of September on floating offshore wind, and see you then. Thank you very much to all of you present here today and to our speakers, and see you next time.
Thank you. Good to see you.
Thank you. Yes, the PowerPoints are going to be part of the library. If you are a member, you will have access to it. If not, we invite you to become a member.
And the video recording, Georgiana, am I correct in that?
The video recording are freely available on the DRBF YouTube channel, but also in the library for members. Yes.
Thank you.
Excellent.
And thank you, everyone.
Thank you. Thank you. Bye-bye.